Welcome to the African Plants Georeferencing Train the Trainers workshop. This is questions and answers session 4. We're going to review all the concepts that we have been learning during the course. And so we're specifically talking about module 5, which is integration of all such concepts. So, welcome everyone. And for today, we have a series of exercises that we're going to try to do all together. I'm going to show how they are done, but I will be asking you questions and see if we can do this as participative as possible. So the idea is that we will have a set of locations that you can see on the screen, and we're going to georeference each one. So each of the type of locations that you see here is one of the locality types that you will find in the georeferencing calculator. So can anyone tell me which type of locality are these? Let's start with that.
Hello?
Hello.
Yeah, coordinate only.
Very well.
Geography
Yes.
coordinate only.
Yes. Excellent. Coordinates only and geographic feature only. Yes. And the next ones. You can say it on with your voice on using the microphone, or put it on the chat as well. We have on the chat one distance at a heading, but which one is distance at a heading?
I see in
I couldn't understand what you said, Michael. If you could repeat it.
number 2, geographic feature only.
That's correct. Yes, geographic feature only. Then we have, see on the chat, people say that distance at a heading is number 3. This is 1, 2, 3, and this is not distance at a heading because we're missing something that is the heading. Heading means when we have a direction, so south, north, east, west. So here we don't have a heading. In this one, we only have a distance. So this one is distance only. And the next one would be distance at a heading, because we have a distance and a direction specified. So what about the last two? Ideas?
Hello?
Hello.
The last one is distance along orthogonal directions because there are two directions being given in the question. Okay.
Excellent. Yes. The last one is along orthogonal directions. And we're missing this one here, where we have a distance and a direction, but we have a part that is specifying a route, a particular route, road, highway. We don't know what it is, but it's a route, it's a path. And so this one is a distance along a path. So with that, we complete all the locality types that we have available to use in the calculator. So what we're going to do is georeference each of these ones and see how they look. So we'll do the whole calculation for each one. So I'm going to start with the first one. And as you well said, this is coordinates only type. Why? Because the most specific part of this description are the coordinates. So I'm going to switch between the presentation and Google Earth and the calculator so that we can georeference these locations. So let me wait a second. We're at coordinates only. And I'm going to go to Google Earth here. And I look for the coordinates that were given. What I do is copy these coordinates because here I don't know where they are. I only know that they are in KwaZulu-Natal, in South Africa. So I'm gonna look for these coordinates in Google Earth up here. Search. Let's see, I have one space too many here. There. And so those are the coordinates here. So I find them there. So in that spot, I will put a marker just for the sake of seeing it. Those are the coordinates that we were given in that description, that location description. Coordinates fall inside this town that is called Winterton. So those are my coordinates. So now this is a coordinate only calculation. So let's go see what the calculation requires. Which are the parameters that we need to fill in? So here for locality type, we choose coordinates only. Okay. Which is the coordinate source? Where am I getting the coordinates from?
From Google Earth.
I am not getting them from Google Earth. What I'm doing here is look for them in Google Earth. But where did I get them from? How did I know those coordinates were those? In the chat, we say GPS, that someone says GPS, and no, it's not GPS either. Let's go back to the description that we had. So we had these coordinates and some other information. That is higher geography information. So one more message in the chat, locality description. Yes, that is correct. That is where we're getting the coordinates from. We're getting it from here. They are described here. So what we have to choose in the calculator is locality description. If whoever wrote the locality got those coordinates from a GPS, they didn't say that. To be sure, here in the description, it should say that they were taken with a GPS. But if it doesn't say, we cannot assume that. So we go to the calculator and we say the coordinates come from the locality description. Okay, which were the coordinates? We had them here. This is one coordinate. I'm going to paste them in the calculator just to have them in hand. I think they are the same that I already have. Yes. Okay. So these are the coordinates that were provided. Let's look at the coordinate format. The coordinate format can be decimal degrees, degrees decimal minutes, or degrees minutes and seconds. And in this case, we have them already in decimal degrees. So this is decimal degrees. What is the datum? Or rather, which is the datum that we have to choose for these coordinates? And Peter says not recorded. What do the rest think? Do you agree with that? Do you disagree with that?
I do, because it's not part of the question that gave, we're not recorded. So I do. On my part, I do.
Okay. Anyone else? Either agrees or disagrees? See the chat. Alexis says WHS84, and then Bushali says datum not recorded. Okay, so the datum is indeed not recorded. Why it's not WHS84? Because we don't know really. When we see the description here, it doesn't say which datum were those coordinates in, which datum we're using as the reference. So if we don't know, we cannot assume anything. And so we say, we don't know, it's not recorded. So here, datum not recorded. The precision of these coordinates is, this is a question, which is the precision of the coordinates? Remember that we had these kinds of options.
I think it is exact.
Jennifer says exact. Giles says exact also in the chat. Bushri says 1, 2, 3, 4, 5 with six decimal places. Alexis says exact. Well, you're all correct. It is exact, and it is with 6 decimal places. Really, that is correct, Bushri. Only that on the list we don't have that option. We only have up to 5 decimal places, and so we don't have the option to choose that, which is the real precision, and so we choose exact. But all your answers are correct. Okay, so once we have dealt with that, we only have to complete measurement error and the units for that error. Remember that measurement error is my own error when I measure. In this case, I'm going to set it to 2 meters, but as we were saying before in previous classes, you should calibrate that measure with your own error. But I'm going to leave it at 2 for this example. So we have all that we need, so we're going to calculate the result of this georeference. So we have a latitude and a longitude that for coordinates only are going to be the exact same coordinates that we used as the input. And we have the uncertainty in meters, which is 5,293 meters. That is more than 5 kilometers. Which is the parameter that you think is contributing most to this uncertainty? Remember that the uncertainty has different sources. They can be the precision, can be the measurement error, can be, if it was a GPS, the GPS accuracy, can be the datum. We can have several sources of uncertainty. In this kind of location that we have here in this example, which is the source that contributes the most? We have some answers in the chat. One answer is precision, two answers are datum. Another answer is coordinate source. Well, what is contributing the most to this uncertainty here is the unknown datum. Not knowing the datum can be very bad. So let's see what would happen if we knew the datum was any of this. Let's say WJ84. And let's recalculate the uncertainty. It goes from 5,000 meters to 2 meters. I will do it again so that we actually see the values again. We have 5,000 meters of uncertainty if we don't know the datum. But if we knew the datum, it would be 2 meters. And these 2 meters will be coming from my measurement error directly. The precision is not contributing because we're saying it's exact here. So it's not contributing to the uncertainty. What is contributing is the major, by far, contribution is not knowing the data. So you can see the differences are like very, very large. Okay, so with this, we have finished georeferencing this locality description, which was coordinates only. Remember that you only have to report the coordinates, latitude and longitude, the uncertainty in meters, the datum, in this case will be not recorded, the precision, and all the georeferencing metadata, that is the date, who georeference, the protocol that we use, etc. And if we use some source, the sources, in this case, we just use the locality description, so we don't have any particular source. So here in Google Earth, I just kept that dot there, the point, so that we have it to compare when we georeference the rest of the localities. It was just a point that falls within the town of Winterton. Okay. Now let's go to the next location. The next location is Winterton, KwaZulu-Natal, South Africa. As you well said, this will be a geographic feature only type of calculation, where the most specific part is Winterton. So we would have to look for Winterton on a map or on GeoPic or wherever we want to look for it to see where it falls, first of all. So let's go to GeoPic. In GeoPic, you will see that Winterton. If I look for Winterton there, I can find it in KwaZulu-Natal there, and it gives me a point. So there is no polygon that I can use. So I could either draw a polygon here or draw a polygon in Google Earth. If I draw it here, this will calculate the uncertainty for me and will give me all the georeference, but I'm gonna do it on Google Earth so that you see again how to do it there and we can compare with the rest. So Winterton is here. Let's not look at this one. And so what would be the first thing that we need to do? What should we do here to reference that?
We have to get the center of the geographic center and the corrected center. Then we can draw our circle and get the radius and proceed.
Exactly. That's what we want to get. We want to get the corrected center and the radial. And to do that, we will need to, as Pushari is saying in the chat, we will need to draw a polygon around the town. And then, as Michael was saying, draw a circle and find the corrected center on the radial. Excellent. So to draw the polygon, you had the polygon tool up here. In Google Earth, I already drew the polygon, so I'm going to show you my polygon. You could draw it differently, but here I have my polygon for Winterton. And what we're going to do is try to find the corrected center for this polygon. So remember that you can center this polygon on the screen if it's easier for you to do, and then with the ruler here, we go to circle and draw a circle around this polygon until we get the minimum circle that includes all the town. I'm going to clear this because I already have a circle for Winterton. So when you draw the circle with the ruler, remember to write down the radius, because when you save the circle, the radius will not be recoverable. So I wrote down my radius for that here on a little piece here. I said the radial for Winterton is this amount of meters. So I have my circle. Then I can center my circle and find the center of that minimum circle, which in this case, because it already falls within the town, is going to be directly my corrected center. So I have my corrected center, and I wrote down which was the radial of this circle. So now we have all the information that we need for the calculation. So the corrected center, if you look at the coordinates, is this one. So latitude and longitude. I'm going to paste that into the calculator. So let's go to the calculator. We have here feature, geographic feature only. What is the coordinate source in this case?
Please, did you use GeoPic? If it is, then it's coming from there, but I'm not sure if you use GeoPic or Google Earth. That should be one of them.
I did not use GeoPic for the coordinates. What I did was find here, I found the town. I made the polygon around it. I drew the circle, and I find the center of that minimum circle. And from there, I get the coordinates.
Then Google Earth.
Exactly. As someone was also saying, Benford was saying on the chat, is Google Earth. My source of coordinates is Google Earth. It's not locality description. Someone was saying in the chat it is locality description, but we don't have that in the description. The coordinates are not there. I'm getting those from Google Earth. And so here, the coordinate source is Google Earth after 2008, because my version is newer than that. And I will paste the coordinates here for that point. So there. Those are the coordinates of my corrected center, which, as we saw before, they are in decimal degrees. The precision of those coordinates is exact because I'm having also 6 decimal places, and there is no option for that, so the precision is exact. And what is the datum now?
Still not recorded.
Any others? Giles says W284. W284, W284. Okay, we have several votes for WGS84, and that is correct, is WGS84. Why? Because the coordinates, we're getting them from Google Earth, and Google Earth uses that datum. And so if we get the coordinates from Google Earth, the datum is WGS84. So we have completed all the parts about the coordinates. Let's go to the radial of the feature. Remember that the radial of the feature is the radius of this circle, which I wrote down here. The radial is that one for that circle. And I'm going to put it to the meter. I'm going to round this up to those amount of meters, 1,674. Remember that the distance units have to be consistent for all the distances or measurements that we put here. My measurement error, my personal measurement error, I will keep it at 2 meters. And so now we have everything we need to do to calculate the georeference. So I'm going to calculate, and we get a latitude and a longitude that are going to be the same that we put here, because it are the coordinates of the corrected center. And we have an uncertainty associated with this location. So I'm going to ask you now, which is the main component contributing to this uncertainty in this case? Oh, we have a question here that says, why are we using exact as precision? Because here we have 6 decimal places. And so the precision truly should be 0.000001, right? 6 decimal places, 3 and 3. Now, when we go here to the options that the calculator gives, we don't have, we don't have that option. We have up to 5 decimal places. And so we have to choose exact. We have to say that the precision is exact for the calculation. Okay, good. We have another question that says, I can see measurement error is 2 meters in both examples. Why? Well, the measurement error is the error associated to my Paula, my capacity for measuring on a map. And so I have to determine that by measuring several times and see how much I get how much difference I get between my own measurements. And so, for example, if I measure here, if I was to measure, I don't know, the radial here, well, let's put it in as a line. Wait, give me a second. Or I'll show you in another piece of, in a little piece of route here. Suppose that I want to measure from here to here. So I measure once and I get a value. Okay, 887 meters. I measure again and I get 879. I measure again. So how different are my own measurements among themselves? So that's my error. That's the error I am committing. So that's something that each of you has to determine, and that, as we were saying the last class, we need to calibrate it every now and then and see if we're keeping the same error or not. The error usually if we are using a good level of zoom, the error is between 2 meters, 5 meters. If we zoom out, of course, we're going to have much larger errors probably because we cannot really see where we're putting the dot. But we should try to measure as close as we can to the features and to the elements that we're measuring. Nestor, does that answer the question? Okay, excellent.
Okay. It's clear for me. Thank you, Paola. Thank
Sure.
you. Yeah.
Okay. So we have now georeferenced Winterton, which is a town. And so we got our polygon, we drew the minimum circle that includes all that town, we determined the corrected center, and with that corrected center and the radial, we could calculate the georeference, and we got this uncertainty here. And so I was asking, what is the factor that is contributing most to this uncertainty? Why do we have this uncertainty of 1.6 kilometers here? Ushari says the radial. Any other ideas? We have a position for measurement error. And some other that agrees with the radial. It is indeed the radial. The radial of the feature is the biggest contribution to this uncertainty. The measurement error really is very low. It's 2 meters against an uncertainty of 1,600 meters. So you can see here that the contribution is due to the radial of the feature. If the feature was smaller, suppose it was 10 meters across, you see that the uncertainty would be much smaller. If the radial was much bigger, say, I don't know, 6.5 kilometers, we would have uncertainties that are much larger. So the radial is what's contributing the most to this uncertainty. I see a raised hand. Michael?
Okay, so let's assume that we have a town which is just like a circle. That will mean that you have a bigger radius, but it is not going to include anyone's much uncertainty. But as we said, if the radius is big, it means that it will be large. Will it also happen that if you have a town which is almost like a circle and have a bigger radius, the uncertainty will be also high?
Let's see if I understand what you're asking me. If we have a town that is a circle, the radial that we use will be exactly the radial of that circle. That tends to happen, for example, let me go to, there are actually real examples of circular features. Let me go, because I know where there are some that I can show you. So let's see, like around here, there are some circular here. There you have it. These are plots, these are farming areas where you see the circles because of how they irrigate the ground. So they irrigate in a circle, and so the circles get marked here. If I was to georeference this one, like field number 3 in this farm, blah, 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 whatever the description is, we would actually have a circle. And so we would come here and say, well, if I had to draw a polygon, I would have to come here and try to make a circle all around, etc. I can do that with a circle already and have exactly the, and here I have the center even marked for me. This is very easy. And I draw my circle here that includes all this location, suppose. This will have its own radial here, and this is the radial that we get, 600 meters. And this will be the corrected center. So we will have a corrected center and a radial. And with that, we do the calculation. And we will get a given uncertainty. Now, suppose that we were not georeferencing this, but a smaller circle here. A smaller circle will have a smaller radial. It doesn't matter the shape that it has. The radial will be smaller, but we can perform the same type of calculation. Now, what we will have is, in this particular cases, that all that we are including in that uncertainty is within the location. For shapes that are more elongated, if we had, for example, this field here, and we will have to draw a polygon like that, no? If we draw a polygon like that, and we draw a circle on top, you will see that there are areas that fall outside. Suppose that this was the corrected, these areas you are including and not really within the original location. But that's, we're accepting that as uncertainty because it's the best we can do with this method. The uncertainty will include other areas that are not included. Not the location, but the uncertainty. Michael, see your hand up?
Sorry, but the reason why I asked this question is that you were saying if the radius is bigger, then the uncertainty will be bigger. But if the radius is bigger for a circle, I don't think the uncertainty will also be bigger. That is what I wanted to be clear. Oh, well, I'm okay.
No, the uncertainty will be bigger anyway. Because what you're saying is you have a place description that is supposed, I will write it down here. See if we can clarify that, because this is a really good question. Suppose that I say, let's write it in some other color that is visible. Plot 1 farm X, Córdoba, because this is in Córdoba, Argentina. Suppose that this is my location, right? So for this location, oh, I close the annotate. It's not going to help. Let's see if I can write it in white there. For this location, what this location is saying is, where I collected the little plant, suppose I collected a plant, can be here, or here, or here, or here, or here, anywhere within that location. Anywhere within that location. So if this circle was smaller, if this farm was smaller, suppose that I had a farm that was, instead of this big circle, was this circle. If this farm is smaller, the location would be telling me that I could have collected in here, or here, or here, or here, or here, or here, but not around it, not in all these places. And so the uncertainty is giving me an idea of how good is or are the coordinates I'm providing with respect to the real place where the plant was collected or observed. Because when we provide a georeference, what we're providing is the center of the circle. However, that center might not be the real place. If I collected, for example, suppose I really collected here, right? Let me clear, let me see if I can erase this circle to make it, wait a second, let me see if there. Suppose that this is the location, and I actually collected it here. I collected the plant there. With this location description, I would come here and georeference the whole circle. And which will be the coordinates that I will provide? The center of that location, the center of this location. However, within that location, we see that the plant was not collected in the center, was collected here, but I don't have that information from the description. So what the uncertainty is telling you is, if you say you collected in this plot, in this farm, you could have done it anywhere in this plot. So if I gave you just the coordinates, I wouldn't be representing the real spot. That's why I give a coordinate and an uncertainty, saying, well, it can be from this point, all the circle around. Now, if the circle was smaller, that uncertainty is going to be smaller. So suppose that this plot in the farm was this big instead. So if this was this big instead, and I provide these coordinates in the middle as the coordinates for the georeference, I could be mistaken by all this area, which is represented by that uncertainty. So if the circle is smaller, the uncertainty is smaller. If the circle was bigger, if the circle was much bigger, like that, the uncertainty will be bigger because I'm including other spaces where the point could be within that uncertainty. Does this clarify?
Yes, very clear, very, very clear.
Excellent. Okay, do we have we have a good question on the chat. That is from Nestor that says how to draw a polygon when the location is in the forest or in the savanna and we have no reference point. It's tricky. It depends on what the locality description says, because the polygon that we will draw has to be consistent with what the locality description is telling. So let's see if I can, let me go out from first here. I will erase all these annotations. So there, okay. And now erase this polygon just not to make a mess. Okay, let me go out from here. Let's go into the Brazilian forest that we have up here. Very much at hand. So in here, we may not have references to draw. Now, if the location says Amazon jungle, we're screwed. Sorry for the vocabulary. I mean, we will have a very, very large space that includes all the Amazon, and we cannot draw a smaller polygon than that. Now, if we have a location description that is more specific and says around the town of or X kilometers south from, or the junction of Iridia River and Virinova River. So depending on what the description says is the polygons that we can draw. If it says south of some place, well, we have to determine that place and do the calculation with distance, the heading. But it depends. You have to look at each description in particular. We have another question that says,
yeah, Paula, please.
Yes.
Can we review? Can we take an example about the exercise 9 Jingada? Example with exercise 9.
Exercise 9.
9 on Dengada.
Before we move on, could I ask a related to this question before you move on from that place?
Yes.
So let's say, for example, you put like the same example where you're in the Amazon or whatnot, and maybe the only reference you have is like a small town or a road nearby. But the reference point itself is quite far from that town. It's, I don't know, like maybe 100 kilometers or something. Do you then, like for the radius, do you then take the point radius for that town, or how do you go about that?
Well, that depends again on the locality description. If we have that says X kilometers south, 100 kilometers south from a town, we would have to use here in the calculation, we would have distance at a heading, and what we will need is both the radial of the town and the distance. The uncertainty will be huge due to the distance. If the distance is very, very long, if it's 100 kilometers, the uncertainty will be very big. But we will need to use the town as a reference and get the radial for that town, then put the other parameters in the calculator and get the overall uncertainty. We will see one example of this when we see from the town that we were looking at before. In here, we have one that is small distances, but it's more or less the same example.
All right. Same concept applies if the actual point is somewhere very far in the ocean, for example, for whatever reason. If it was, yeah.
Yes, only that in the ocean, what happens is that you will usually have coordinates because you don't have towns in the ocean. You don't have many references unless you have how do you say the boshas or
A buoy.
buoys. Unless you're taking buoys or something that is floating out there as a reference, which has to be a fixed reference, you usually find coordinates. And so you will not have distances from a random place in the ocean. You can, however, have distances from the coast. And in that case, your feature will be the piece of coast that is described. So for example, if you say 10 kilometers into the ocean from the coast of town A, you would have to determine what town A is there to have as a reference, because in that case, you don't really care if it falls in the ocean or not. It's the same if it falls in the ocean or if it falls in land. What you need to know is where the coast of that town is. So you have to determine the coast of that town to have as a reference. And you will have a radial as well for that feature. John, you wanted to say something?
Yeah, there's a practice in marine type locality descriptions if it's not in the open ocean, but there is in fact something to cite on land that what will give is the direction in degrees from where the boat is to something, and usually something very specific like a lighthouse. So the feature is very small and the direction is very precise. It's a degrees to a lighthouse. And so those are actually end up being very good descriptions as long as they can determine the distance very well. That's the harder part sometimes.
All right, thank you.
Oh, sorry, I was muted. Sorry. I was saying that if the boat was here and the lighthouse was there, what they would report is this distance and this angle here with respect to the north. So it would be 280 probably degrees and the distance to that lighthouse. That was what John was mentioning for marine. So, okay, I have to go back to some questions here. I will go back to the example, Nestor, that you were asking in a moment. But I want to make sure that we cannot answer other questions that are left there before moving to that. So there's one question from Peter that says, how does one get coordinates representing an entire polygon or circle? Well, if you're going to represent that with a single pair of coordinates, you could only provide the center of it. So for a circle, it would be the exact center of the circle. For the polygon, it should be the corrected center for our purposes, which is a point that is centered and falls in or on the border of the polygon. A better way to represent a circle, a polygon, is provide all the points that make up that polygon. And so you would end up with a series of coordinates that define each of those points and then allow you to draw the polygon when you join those points. But if you're not going to represent it like that, like a polygon with all of its points, you will have to provide the corrected center.
Hello, Paula. Can I add a follow-up question?
Yeah.
Do you do that using place markers, or how do you do that to get them in, let's say, export a KML file or something? Assuming you have your points, you want to get a polygon and export into another software for more development.
If I understand correctly, you have already the polygon.
You have already your points, and you just want the KML file out or a shape file. So you input your points to form the polygon, and I'm asking, you do that by place markers, or how do you input them one after the other to form the polygon?
No, to form the polygon, if you're using Google Earth, you just go to the polygon and you draw it, and each point will already be captured. And so when you save your polygon, you can then export it as a KML, and each point will be captured in that polygon. If you do it in GeoPig, for example, it would already give you in the results all the polygon with the points of each one. Is this what you're referring to?
Would you want to come again? Would you want to come again?
Did you say it again?
Would you want to repeat?
Yes. When you want a polygon of what you do is directly draw on it. So draw it. So if I wanted a polygon of this lagoon here in Google Earth, I would just go here to the polygon tool and start putting the dots. So I can put the dots there, and you see that it will capture already the dots that you're adding to that polygon. So, but I'm gonna do it just fast. So that polygon is already set, and you could save it. I want to say okay here, and I can export it or save it as a place. I can save it here like X polygon. I'm gonna be very
Great. So, here's the situation. You don't really know the place. Somebody gives you the points or the coordinates. So it's quite difficult to go in the, you might deviate or make a mistake. And that is the situation I'm trying to describe. Assuming you don't know. If you know, it's quite easy, or you can manage through drawing a polygon. But assuming you don't know, where the search chart is also not friendly to pick several coordinates at a time.
Well, if you don't know really and you have sets of coordinates, you can only put the coordinates here and start putting place marks, and then you can build your polygon following those place marks. So suppose that you have a coordinate, one coordinate that was given here. Okay, I'm gonna say okay to that. Then you can put another place mark and you place all your coordinates. And once you have placed all your coordinates, suppose I'm going to make one here, right? And you have another one, and then I have another place mark that is out here. And so if you have a set of coordinates that you don't really know exactly how good they are, first you have to trust the coordinates that you have, because that's all you have. And so if you want, if someone gives you all those coordinates and tell you, well, it's within the polygon defined by those coordinates, well, you can put them here on the map and come with a polygon and follow that and say here to here to here and draw the polygon following those coordinates. Does that answer the question?
Great, that's all right. I was expecting a more magical way.
Well,
Thank
you could put the
you.
set. You could put the set of coordinates. You could concatenate them and make a KML and open it as a file as well. If there are very few coordinates, you can do it by hand. It's going to probably be fast. But John, you wanted to add something?
Yeah, if someone was just giving you a set of points like that, that would be very cruel. What you would want from them, if possible, is some kind of representation of a polygon, either a KML or a WKT or something you could export from a shape file, anything except the individual points to have to put on the map yourself. And then import them.
Okay, that's great. Someone says that we do have an online tool to estimate analog feature that is away from the center. But a follow-up question, John. I think Paula started with something. You said if we could, did you say if we could catalog all the points and open as a KML file? You mentioned something like that. Maybe I would want to try that.
Right. If they could be captured directly as KML or a WKT or a shape file from a GIS, any of those, if you have it, could then be transformed into any of the other ones. So, for example, a shape file from GIS, you could turn into KML, and you could put the KML into Google Earth, or you could convert the KML or a shape file to WKT and then import that into GeoPic. I mean, as soon as you have any kind of representation of the shape as a standardized shape format, then you can transform them for whatever tool back and forth. Looks like Paola's showing a WKT from GeoPic now.
Yeah.
I'm muted. I'm so sorry. If you see me talking, please let me know. The output from Geopic for the town of Bamako, and it has a polygon, and so here you can extract the WKT format for that polygon, which has sets of coordinates, latitude and longitude, that are for each of the points of the polygon. And so this polygon has a lot of points. I'm going to look for it again without the circle so that you can see it. Oops. Well, there. So that's the polygon. And so if you zoom in, you will see a point, and there are a bunch of points that define this polygon. That's why this is so big. But you could have a polygon that is a square, and so you will have 4 sets of coordinates. So this one, this one, this one, this one, and from here down, we erase everything. So this will define a square, right? 4 points define, well, a square, no, rather a quadri. How do you say it in English? 4 sides geometry. So if you have it in this way, you could save this as well-known text and import it into Geopic, or turn it into a KML and import it into Google Earth. And you can have as many points as you want defining this polygon. So if someone is providing you the coordinates of each point, you could build it like that and convert it. There are several tools online that can convert it to different formats, to KML, to GMZ, etc., so that you can open it in Google Earth.
Yeah, that's great, Paula. But I was taken away from the meeting, so I just missed the parts where you put them into this format.
Oh, into this format, I didn't put them. I just took the output from Geopic here. I just copied the results to get the points of that polygon. But I think the important part here is that if you have a list of points, you could put them like this: the latitude space, longitude, latitude space, longitude. Actually, the other way around is longitude space, longitude space, latitude, etc. And you can list all the points and build your own WKT.
Okay.
So if you want, we can see it further, and we can follow up on this on email, and we can send you some examples and some tools that might help you with this.
Great. That will be highly appreciated. I would love that. I would love that.
Okay.
Thank you very much for the help.
Sure. So, John, have you followed the chat? Because I'm a little lost in there.
I think so. I think you answered Peter. And then Nestor had to leave before the example was given. And then we get to ask the question: how can I capture uncertainty values in coordinate uncertainty in meters, please?
Well, the uncertainty value goes directly into coordinate uncertainty meters, because in Darwin Core, that field is exactly for that purpose, to capture the overall uncertainty of the location. So that means the uncertainty that we get here in this calculation. This value for uncertainty, this value for uncertainty, whatever we have here, is what is reported using coordinate uncertainty in meters in Darwin Core.
May I make an observation here while you've got that
Yes.
calculator up? So the row where that uncertainty is given, there are 4 boxes: one for latitude, longitude, uncertainty, and datum. Those 4 boxes contain the minimum best practice georeference. You need those 4 things. And the rest is good to have. But those are the minimum.
Okay, more questions here.
Did that answer your question?
You're muted. John.
Did that answer Raymond's question?
Well, I see Raymond has another question here that we can take, given that we're here. That says, if it says coordinates recorded with GPS, what latitude, what would you use as a source? Well, as the source. Now in there, you will get a new field to fill in, which is the GPS accuracy. Which in this case, with the description that you put on the chat, we don't know what the GPS accuracy is. And so we will keep it empty or put the best practice. I can't remember if it suggests any GPS accuracy in particular over time, because the accuracies of GPSs have changed over time as technologies get better. So we will have to check which would be the value depending on the date that the coordinates were recorded. John?
Yes, there are 2 magical numbers to remember. If accuracy is not given at the time the GPS recording was taken, and the recording was taken since May 1st, 2000, that is more recently than May 1st, 2000, then a good default number to use for GPS accuracy is 30 meters. And if it's before May 1st, 2000, that number has to be at least 100 meters. It's because on that date, there was something called selective availability that was turned off. In other words, the satellites that gave GPS readings were actually fuzzying the values on purpose so as not to be as accurate as the satellites were capable of. Therefore, the only people who had access to high value, high accuracy GPSs was the US military. Since then, since May 1st, 2000, GPS was allowed to be as accurate as it possibly could be. And since then also, other GPS systems have been put in place by other unions, organizations, and countries. So there are actually lots of different ones, but all of them have open accuracy readings. They're as good as they can be. So magical numbers, 30 meters since May 1st, 2000, and 100 meters before May 1st, 2000.
Thanks, John. That's if we don't have the accuracy, because we might have the value. Actually, I'm going to go back now to Alexis' question. Is this, do we have any online tools to estimate the angle on the feature that is away from the center? I inquire because some should notify us that you have to georeference a certain location, discover 64, for example, kilometers northeast of a given town. So if we are X kilometers in a given direction, we will be at the distance at a heading. And in here, we could specify that direction. If it's within 3 specifications, I mean, we don't have among the options east, north, east, because that gets. However, we could here even put the degrees directly. So if we had 15 degrees from the north, we could put here the degrees. So the calculator already gives us the options that we need to reference that. So if you have 64 kilometers, here would be 64 kilometers northeast. So I look here for northeast, and that will do it. And so you would have to find the town, that is the reference, find the radial of that town, etc. And you can put the direction and the distance here. There is, however, a tool that we showed in Google Earth that was, is it here? Yes. If we're measuring, for example, from this lagoon to this lagoon, and we're moving and we're at the line with the ruler, we could put the center of each one, for instance, or put a point to say, well, my point is here with respect to the lagoon. Google Earth gives you here the heading, how many degrees from the north. So if this one was the north, here we have north, what is giving you is this angle here. From this point, which you have to determine, it would be the center of the lake or the center of the town or the center of the reference feature, whichever it is, you put your point and you can get the degrees. And with these degrees, you can go to the calculator, and instead of saying kilometers northeast, kilometers northwest, you would say kilometers in X that many degrees, which were 38. So 38 degrees here from the north, and you could do the same calculation. Yes, John.
I've added a link to yet another tool online into the chat. It's going to be further down from where Alexis' question is. And that tool actually does lots of interesting things that none of these other tools will do. It does what Paula just described via the calculator and via Google Earth, but it does some other things as well. So that might be interesting to look at.
Sorry, muted again. We have one more question on the chat pending from Bernard. Is there any way to import a polygon into Geopic, either Google Earth or Google Maps? And oh, you answered in the chat. Okay, but I'm going to say that loud because it's important to keep it in the recording as well. We can import polygons into Geopic, but only as WKT in WKT format. And so, for example, I'm going to reduce this here. Suppose that we want to, that we want a polygon here, and I'm going to draw it so that you can see. I'm going to do that just for the sake of having a polygon to show you. And okay, I believe this one is okay. So I'm gonna paste it somewhere just to have it. There, that's the polygon that I just drew. It doesn't matter which polygon it is, but here we have the well-known text polygon that is that part there. That's the polygon that I just drew. So if I had it in this format, which has longitude, latitude, longitude, latitude, longitude, latitude for each of these points that I drew, this one, this one, this one, and this one. So I could copy paste that, and I'll show you what happens. I will clean this all up. Okay. And I go to somewhere else in the world. So I'm trying to find the polygon that I want. Okay. So I can go here to the WKT, a little window, paste the polygon in this format, in well-known text, and click OK. And so that will take me to the polygon I just pasted, which can be big or can be small. I put just 5 points for my polygon. But if you have any polygon in that format, WKT, you can come here, again, I'll show it again. You can come here, WKT, and paste the information in this little box. Click OK, and it will draw the polygon for you on Geopic. To import a polygon into Google Earth or Maps. You can import polygons, but you can in Google Earth you can import polygons if you have them and just open them in Google Earth. I think we have shown that before as well. And we have one more question in the chat that says, what is the recommended unit for the distance unit and the precision unit when using the calculator? Well, I will put, let's put one that is easier there, just not to have so many fields around and what. The units, number one, the units have to be consistent for all the values that we're putting here on the right. They have to be consistent. So if I'm putting precision and radial and offset in kilometers, this has to be kilometers. Now, if I'm using kilometers, I cannot put this in kilometers and this in meters. I mean, everything has to be in the same unit. So one or the other, we need to convert. Now, when we use offset distance, we're usually taking that from the location description. The description says 10 kilometers from some town. And so they are already giving that in a particular unit. So, for example, if I say 10 kilometers from Bariloche, that is where we are, I have that, 10 kilometers from Bariloche. The description is already giving me the unit. So here, this is the unit that I have to use because that's the unit that is given. And so when I determine where Bariloche is, I draw the polygon, I get the radial, etc., I will have to put that radial in kilometers, which 4 kilometers, right? But always they have to be consistent in the unit. And if I have kilometers in the description, I will use as a distance kilometers and convert the other one. If I have meters here, I will use meters and so on. And the precision will be also in accordance with those units. If here I choose meters, see that the precisions that we can choose are in meters. If here I put miles, the precisions from which I can choose are already in miles. So they change automatically so that we can choose a distance other than whatever the unit is in the description. That is not just the recommended, it's the one that we have to use. Does this answer your question? We missed another question from Raymond. Like, wait, where? I think I have already answered that. When we have GPS, we have to choose GPS as a coordinate source. Yes, I already answered that. Okay. I see no other questions lost in the chat. But please let us know if we skip some because we're jumping from one to the other. Okay. I propose we have only seen, let me go up here. We have only seen 2 examples of the 6 that we were going to see. We have seen the coordinates only and the geographic feature only. We still have to see the other 4, which have distances. So I propose that it's already 1 hour and a half into the session. Would you agree to have a break now, 10-minute break, and we come back to finish these localities? I tell you all that there were very, very good questions today. Really good questions. Would that work? Should we go to a break? We have one positive vote there. Okay, this is still running. Okay. We have a couple of votes, so okay, let's do that. Let's go to a break and we come back in 10 minutes and we continue. Okay, we are back. So we will continue with the georeferences of the other locations that we have on the list. And let me answer one message here from someone on the chat. So we're going to go now to the distances that we had pending. The distance is the location. So we've seen the the coordinates only, the geographic feature only, and now we have all this in here that we're going to try to georeference. So we will start with the first one here, and this one says 3 kilometers from Winterton, which is the town that we were looking at before. And this is the most specific here in blue, the most specific part of that location. Remember that for georeferencing, the first thing that we have to do is look at the description, determine which are the parts, and then look for the most specific part to do the georeference, which is this one in blue. So if we look at the calculator, well, we had said before, sorry, that this is the type of location is distance only, because we only have a distance from a place. And so for distance only here, we will need coordinate source, coordinate format, the the input coordinates, datum precision, what is the distance that we're dealing with, and the radial of that reference feature. So let's go to Google Earth. Let's go back to Winterton, which we had already determined. We had determined the polygon for this city. We had made this minimum circle around it. We found the radial and the corrected center of that town. So I think we have all the information that we need, because the location was 3 kilometers from that town, and in the calculator we need the coordinates of the town, its radial, and the distance. So the coordinates here are the coordinates of the corrected center. So let's look at them again. Latitude and longitude, which are the ones that we already have as input here. These coordinates are coming from Google Earth, because that's how we determine the center. They are in decimal degrees. The datum is WGS84, because we took those coordinates from Google Earth. The precision, since we have here 6 decimal places, is exact, because we don't have an option for 6 decimal places. The offset distance is the distance from that town, which was in the description 3 kilometers. It is in kilometers, so that will be our unit. So here we put 3 kilometers. The unit here we select kilometers. We select a precision of 1 kilometer for this distance, and we have to put the radial of the feature, that is of Winterton, which we had already determined when we draw the circle. And the radial of that, I have it around here, was this, which we have to put in kilometers. Remember, it has to be in the same unit of the offset. So we're going to put 1.67, we're rounding this up, 1.67 kilometers. So here, 1.67 kilometers. My error, again, this error is my own personal error. I said it was 2 meters, so 2 meters is in kilometers, 0.002. And so we have all the parameters that we need to calculate the georeference. And so we get a latitude and longitude, which are the same as the input, and we get an uncertainty. So which are the factors that you think are contributing most to this uncertainty? Ideas? Boucherie says the radial of the picture. Any other? Okay, let's analyze that of the radial of the feature. The radial of the feature does contribute here. So, for example, if the radial was much smaller, let's put 0.5, the uncertainty would go down by 1,000 meters by a kilometer. If the radial was even smaller, I'm exaggerating here, we will go down also in the uncertainty. However, we don't go down that much. We're going down like a 20% in the first case, and even less as we go down. This was 1 point. The original was 1.67. So which other, the radial of the feature does contribute to the uncertainty. Which other factor, which other parameter can contribute to having such big uncertainty? The datum cannot be, because we know what the datum is, because we took the coordinates from Google Earth. So which is the other parameter contributing? We have 2 suggestions here. One is the distance precision, and another one is the offset distance. Well, the distance precision does contribute, but not that much. However, let's see how it would change. If instead of a kilometer, we were being more precise and we would have half a kilometer in the precision, we would go down, but not that much. So the precision in the distance is contributing, but not very much for this value of distance. So let's go back to 1 kilometer. And the offset distance is the other option. So Let's see what happens if we have a much smaller offset distance, let's say 0.3 kilometers, and see how it changes. It goes to half. So the offset distance in this case is contributing a lot to the uncertainty. If we went to a much higher offset, let's say 100 kilometers, the uncertainty will go much higher. Much higher. So the offset distance is the factor that is driving mostly this value of uncertainty. So going back to, this was 3 kilometers, just to have it there. This is the uncertainty that we got. This is the whole georeference. So we have georeference a location that is 3 kilometers from the town. And 3 kilometers from the town, keep in mind that is 3 kilometers in any direction, because we don't have any direction specified. So it could be north, it could be west, it could be southeast, it could be and just any direction. So it's not very specific. This description is not a very good locality description. Okay. So now let's move to the next one, which is similar, but it's specifying a direction, a heading. So this one would be distance at a heading from this particular town of Winterton. So if we go to the calculator, we will choose here now distance at a heading. And we would need, well, the same coordinates, the source of the coordinates, the datum, etc., which we already have because we're referring still to the same town, Winterton, so we don't modify this in this case. We have the direction, which was here south. So in the calculator, we will choose south. We have the offset distance, how many kilometers south, which is going to be the same in this case, 3 kilometers. The radial of the feature is the same because we have Winterton as the town, and all the other parameters remain as we had them before. So we calculate here and we get this uncertainty. So here the question that I have for all of you is, why, if the place is the same, the radial of the feature is the same because it's the same town, we have the same distance, the same measurement error, we know the data. If all of these parameters are the same, why in this case the uncertainty is smaller than in the previous case that was 5,000 meters? In this case is 3,000 and something. Why is this uncertainty smaller?
I've typed a response.
Okay. Exactly. We have two answers in the chat, and both of them say it's because the precision of the direction being south, we're more precise because we have a direction. Before, we didn't know 3 kilometers to which side of the world. In this case, we have a particular direction. And so we're being more precise, and so we're less uncertain. The uncertainty is smaller. Perfect. So if the direction was more specific still, and instead of saying south, it would say some southwest, oh, southeast, I'm choosing southeast. So the uncertainty will be smaller still because we're narrowing down the direction. So perfect. Okay, so just to look at it on the map, because I have the points to show you, I will get rid of the circle here. And we have, this is Winterton, the correct center for the feature only. The first one that we georeference were the coordinates given, which were some coordinates that fell in the town. These were the coordinates for the geographic feature only description. The ones for 3 kilometers Winterton are the same as the feature only, because it's 3 kilometers from this point, so the point is the same. And now we can plot the 3 kilometers south and see that the coordinates of that point are really in the south. These are taken from the calculator, and then you see here, when we calculate it, these coordinates are different. The longitude is the same because we're moving straight south. So the longitude is the same, but we're moving in latitude to the south. So the calculator already moves the point to the south and gives us a more specific point. And so when we plot that result, the result is 3 kilometers. See, that is directly south from the center of the city that we determined before, the corrected center. 3 kilometers south, proof to the south. Okay. Now, we have to move to the next location, which is 3 kilometers south of Winterton on this particular route, R600. So let's look at it on the map. R600 is this route that goes through here and goes kind of south to the next town. So the location description is telling us that they moved 3 kilometers south, but on this particular route. So the way in which we georeference this has a couple of steps that we need to follow. So I'm going to not show this so that we're not confused. I will keep the polygon though for Winterton, and I will go into here, and we will see that R600 has a part that is inside the town. So we don't know from where those 3 kilometers were measured. They could have been measured from where the R600 starts or from the limit of the town and the 600. So we need to first determine a center for that little piece. That means the point from where we will start to measure the 3 kilometers. And so what we do is draw a new polygon that includes the overlapping of that route and the town. So I have already drawn that polygon there. You can do it just drawing a polygon as we always do. So that's the polygon of R600 inside the town. That is going to be our new feature here, our new reference, because from the center of that, we measure the distance on the highway. So we need to determine the center of this polygon, the corrected center of this polygon. And so what we're going to do is draw a circle around it, just as we do with any other feature, and find the corrected center of that feature, that red feature here. And so when we draw the circle, we get the radial and we get the corrected center, just as we did before with the town, but with this new polygon, with this new feature. Now from that center, we can start measuring on the route the 3 kilometers. And so we will get our ruler here, go to path and start plim, 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 all over the route until we reach 3 kilometers. And so I have already drawn that. And so I started in pink, with a pink line. I started from there and I went on R600 until I reached a distance of 3 kilometers that ended around here. So I will say it again. We have a description that says 3 kilometers south on R600. This is a distance, but is on a particular path. It's on this particular path. So what we do is find the intersection between the reference feature, the town, and the route, this path, that is R600, we draw that polygon, we find the corrected center of that feature and its radial, we start measuring the distance on the given route. So when we go to the calculator to do the georeference for this one, we will not use the corrected center for the town. We will use the corrected center for this new feature because this is going to be our reference feature now, this intersection between route and town. And so we will use this corrected center and the 3 kilometers on the route. So for this corrected center, I have, let's look at the coordinates of that. I have to copy the latitude and longitude of that corrected center. So here is distance along a path. I'm taking the coordinates from Google Earth. They are going to be in decimal degrees. I put the latitude and the longitude of that corrected center. The datum will be WHS84. The precision is exact. And the radial of the feature has to be the radial of this feature here, the red one here, of that overlap, which I have around here, which is 491 meters. I have to put that in kilometers. So it's going to be 0.4 kilometers. And so, now, no, I'm making a mistake here. This is distance along the path. So from here, these are not the coordinates that I have to use. I have to use the following. Sorry, I was mistaken for the other example. Once we have this center, that's why I drew this line. When we have this center, from this center, we measure the 3 kilometers and we get another point. That's the one that I was not showing you here. There. This is the point that goes 3 kilometers south on this route from the corrected center that we determined here. So we will use the radial of this feature, but the end coordinates will be where that distance ends. The last point that we have determined, that we measured, the 3 kilometers. So this is the coordinates. I was doing it wrong, sorry for that. These are the coordinates that we need to copy into here. Latitude, longitude. Okay, now yes, we have the coordinates of the point that falls 3 kilometers south from this intercept between the route and the town. This is the 3 kilometers. We have these coordinates and the radial of this red feature, which is the overlap. So with those data, we can go to the calculator and we already have coordinate. This is all the same. Careful with the units and we calculate. And so we get this uncertainty, which is fairly small. So for this one, which do you think is the factor that is most contributing to the uncertainty? We have one suggestion that says distance. Any other suggestions? Well, I'm going to answer to that one, to the option of distance. And sorry, distance here is not contributing. Why? I mean, you see that we don't have it here. We don't put it anywhere in the calculation. Why? Because we are determining it by hand. We are coming here and drawing this line. And so the uncertainty associated with distance truly is our measurement error in this case, is how well could we measure these 3 kilometers, because it's on a route that we can follow. And so the distance is not going to affect us. That will be included in our measurement error, ability to distinguish where we put this little pin. So which other factors do we have here that can be contributing to this uncertainty? Well, the measurement error, we saw that if I measure those 3 kilometers on the map wrong, that's going to contribute, but in this case is rather small, that contribution. So which is the other factor? Any ideas? Exactly. Ulsheri answered correctly. Is the radial of the overlap feature. Exactly. Is this radial here. So what is contributing is the radial of this feature that we determined here. If this radial is very big, the uncertainty will be big. If this radial is smaller, the uncertainty will be smaller. So let's change it. Suppose that this was, instead of 0.5 kilometers, it was 2 kilometers. We see that the uncertainty goes from 900 to 2,500. If the radius was smaller, much smaller, let's say 0.01 kilometers, the uncertainty goes down from 900 to 500. So that is correct. Is the radial what is most contributing to this uncertainty value? Was this example clear? Because I know I mixed it up a little bit in the middle of it. So I want to make sure that everyone understood how to perform this one. Okay, yes, there is a question in the chat that says, could you please remind me why you go further than the circle? I assume that you're asking, why am I going with this pink line down? Okay, so I will start again. I'll undo this one so that we can see how we got there. Okay, so the location said, let's copy paste it here to have it at hand. Let's put it here. Let's say white down there. Okay. That was the location that they wanted us to georeference. So it's 3 kilometers south from Winterton on R600. So that we have an idea, if this is Winterton, 3 kilometers south would be, I'll show you here. I can get a ruler and more or less see where 3 kilometers are, right? That would be around 3 kilometers south. And if we went on the route here, we would be 3 kilometers south would be going on the route around 3 kilometers. So the location really, the location is here, is down there where that blue dot is right now, where my little hand shows. So that is where the place where the location actually refers to. It doesn't refer to Winterton. It's saying it's 3 kilometers south on this road. And so we need to get to this point, more or less. But so that we keep in mind where we should be. And so the way that we get to the point is, well, we go see here, and we see that the R600 has a part that is inside the town, right? So when we measure the 3 kilometers south, we could be measuring from here, from here, from here, or from the edge of the town. We don't know exactly from where those 3 kilometers are measured. So what we do is say, well, we're going to measure from the center of that piece. So that's why we draw this polygon and we find the center, and we say, well, once we have the center of that polygon, we have to start measuring the 3 kilometers south on the route from there. And so we start from there, measuring down, and we do a line that goes from here 3 kilometers down. If I was here, I wouldn't be 3 kilometers south. 3 kilometers south is down here. So when we measure from there, we get to a point around here that is 3 kilometers south. And with that point and the radius of this feature, we do the calculation. Is it clear why we're going away from this circle? Because this is inside the town. It's not representing 3 kilometers south. 3 kilometers south is down here. Fabrice, does this answer your question? Okay, excellent. What about the rest? Have you all understood how to deal with this type of location? Okay, I have a question on the chat that is a very good one. It's like, why didn't we draw the circle around the point where the 3 kilometers end to find the radial? Well, because there we wouldn't find the radial here because we don't have a specific reference there. The reference here that we have is that we're moving on this route to a given point. The uncertainty associated with radial has to do with determining from where we're measuring. And so here we, as I said before, we could measure from there, from there, from there, from there. So this is our uncertainty in where we start to measure. When we get the georeference, we are going to get an uncertainty, and we're going to say, well, the result is that we can be here, but with a certain uncertainty around it. And so we could draw the final result here. Let me see, the uncertainty was for this one, the final uncertainty, I will have to do the original here, there, is 900 meters. And so I could come here and say, if I wanted to represent this location, I will have to provide these coordinates and an uncertainty that defines a circle around it. And so that would be from here, 910 meters outwards. So this is the location, is the coordinates plus the uncertainty around it. But that uncertainty is the final uncertainty. That final uncertainty contemplates the my measurement error, the uncertainty associated with the radial of the feature that was the overlapping, etc. So if we wanted to represent the final georeference, we would do it this way, with a pair of coordinates and the radial, those 910 meters. And so this is our location. But to calculate it, to calculate that final uncertainty, this final uncertainty contemplates several sources of error. And so we have to calculate, and to calculate it, we need to know the radial of the feature above.
Yeah, the radial of the feature above, and the feature above, if you can zoom up there, the actual feature above is the part of the R600 that is within Winterton. So the feature isn't Winterton anymore. For this one, it's got to be on the road in Winterton. It's that intersection. So the feature is the part of the R600 within Winterton. That's why Paula had to create that polygon for just the road and find its corrected center and then find its radial. That's the tricky bit.
Has this answered your question? Okay. I see there in the chat. Okay, excellent. Okay, if there are no questions, further questions now about this one, I'm going to pass to the next one, but we can always get back to this one. I'm going to take these ones out now to see the other one. I will just leave Winterton there for reference, that polygon. And oops, I'm going to go here to our last one. That is 3 kilometers south and 2 kilometers west of Winterton. This is of the type orthogonal directions. So what we're saying, if we look at the map, let me erase the clear all drawings. What this location is saying is that we're moving from Winterton, from the center of Winterton. Let's put the center of Winterton there for reference. That was the corrected center. And we're moving south and west. So we're moving like that and like that, right? So we're moving 3 kilometers and 2 kilometers. So we would expect a point 3 kilometers south and 2 kilometers west. That's what we would expect. Let's see what we need to calculate where exactly that point is. Let's clear all this. Okay. So what do we need for this calculation? Let's look at the calculator. The calculator is going to help us determine that. So this is distance along orthogonal directions, and we need coordinates that are going to be coordinates of the reference feature with its format, source, datum, etc. And we will need to know how many kilometers or meters to one direction and how many to the orthogonal direction. And the rest is the same. So our reference feature here is Winterton, and we already have the corrected center of Winterton. So those are the coordinates that we're going to use. So let's copy those coordinates. This is the latitude, and this is the longitude. Okay. Again, they are taken from Google Maps. They are in WGS84 datum. And we need to say how many kilometers in this case we're moving south and west. And it was 3 kilometers south and 2 kilometers west. So here we say 3 kilometers south, 2 kilometers west. We're fine. And the radial of the feature has to be the radial of Winterton, which is our reference feature. And so I have that radial copied here. The radial of Winterton was 1.67 kilometers. Where is here? 1.67 kilometers. All the rest is fine. We have our measurement error in kilometers, the unit kilometers, the precision kilometers. So we calculate. And we get this uncertainty. So now the question is, what is the factor that is mostly contributing to this uncertainty? The offset distances and directions. That is one option. The radial. Those are options that we have on the chat. Okay, let's see. The offset distances and directions, in the case of orthogonal directions, can only be straight north or straight south, and straight west or straight east. And so we have no doubt about the orthogonal directions. They have to be that because they have to be orthogonal between themselves. So that will not be contributing to this. Now, what happens with the distance? Well, let's test it and say instead of 3 kilometers south, we have 100 kilometers south. And the uncertainty is exactly the same. Why? Why is it exactly the same? Because we're moving in orthogonal directions. Remember that the offset distance is very important if we're moving in a single direction, whichever direction it is, because the further we go, the broader the angle that is associated with moving in that direction. But in this case, we have a straight, how do you say that? A 90 degrees angle. So it's very, very precise, the directions that we're getting. So it doesn't matter if we move 1 kilometer, 100 kilometers, or 1,000 kilometers, because that's not going to affect our uncertainty in this case. So what is really giving us the uncertainty or contributing most to the uncertainty is the radial of the feature. Again, it depends on how big the feature is. And so again, we could put here a much lower value, and we will get a much lower uncertainty. And if we put it bigger, it will be bigger. Now, you can have an idea of what is contributing to the uncertainty if you look at the actual value of that. This is 2,000 meters, and the radial is 1.6 kilometers in 1,600 meters, and these distances are already 3 kilometers, are much bigger the distances than the uncertainty. So looking more or less at the values, you can have an idea of what is contributing the most. So the measurement error was something that was also, I believe, suggested somewhere, but if it was not, I will say it anyway. The measurement error is not contributing much here because it's very small. It's 2 meters only. So 2 meters actually contributed the most. The radial of the feature. Is it clear why in this case this distance does not figure in the uncertainty?
Yes, because they're even making the location more precise, so they could not contribute to uncertainty.
Exactly. We're making it much more precise. And let me get a clean dartboard here, and I will show you something. Remember that when we looked at how uncertainty varies in directions, we were saying, well, if we move, if we say we move east, we could be moving from here to here. Remember that we saw that the other day? If we only specify south or east, we will have all this error to one side and to the other side. And the further we go, if we move 1 kilometer here or 10 kilometers, if we move 10 kilometers, then the uncertainty is going to be much bigger. So that's what happens when we only specify one direction, either south or southeast or south-southeast. Well, it will vary the value, but we're saying we move X amount to this side strictly to one direction and strictly to the other direction. The option that we have is that the dot is here in the intersection there of those two orthogonal directions. There is no doubt because we're specifying straight north, straight east, or west or south, no? But always these orthogonal directions here. And so that's why it doesn't matter if I move here, if I move 1 kilometer, I get this point. If I move 1 kilometer and 1 kilometer here, I get this point. But I'm not changing the uncertainty associated with that. I'm not changing that arc as I was before, because this has no uncertainty associated. I'm going straight east, I'm going straight north. I don't have an arc here to consider. So that's why that is not figuring in the uncertainty. John, do you want to add anything to this?
That seems clear to me. We need to know if it seems clear to them. Pulcheri says yes with an exclamation point. So that seems great.
Okay. Okay. I'm going to clear all my drawings then. And let's go back to, I think we're done with these examples here. And we have seen some of the things. I will show you how it ends up being this. So this was Winterton. If it was geographic feature only, we had some coordinates that fell on Winterton for the first location. We had 3 kilometers from Winterton. The center is the same. The uncertainty associated will be different, but the center is the same. 3 kilometers south of Winterton. The calculator gives us here the coordinates, and see that it's straight south from the corrected center. Then we have 3 kilometers south on this route. And the final one, which I'm not sure I showed you here, but when we calculated, these coordinates were different, right? Because we were moving south and west. The final point, and that final point falls here, 3 kilometers south, 2 kilometers west. So the calculator gives you the final point and the associated uncertainty. So this will be all the so far. Are there any questions about this? Okay, I'll move to here. We have some other examples that where what happens if instead of 3 kilometers, we had a location description that said 300 meters, which is clearly the same distance, but sorry, 3,000 meters. Sorry, if we instead of having 3 kilometers, we had 3,000 meters, which is the same distance but with another unit. So let's look at that. What do you think will happen if I have distance only? This one is easy. And we have a point and we say 3 kilometers. and we calculate. And this is one of the first calculations that what we did today. 3 kilometers from the town. This is the radius of the town, the corrected center of the town, etc. What happens if instead of the description says 3,000 meters? What do I have to change here? Good. The distance unit. Yes. I have to change the distance units. If I put 3,000 here, I have to use meters because I'm talking in meters, and the radial I will have to change as well because it was in kilometers. I will have to put what it was in meters, which was 1,674, if I remember correctly. What would be the precision here? So this one is tricky because we have to look at the distance and say, well, what's the precision of this? And we have to get ourselves in the mind of the person that wrote the location description and say, well, were they measuring every 1 meter? Were they measuring every 10 meters, every 100 meters? Well, one suggestion in the chat is 1,000 meters. So 1,000 meters would mean that who wrote the location description said either 3,000 or 2,000 or 1,000. Well, if we go to the georeferencing best practices document, we have a table that helps us determine what the precision in this case should be. And in this case, it should be a little smaller than that. It should be 100 meters. And when we say this, we're assuming that the person who wrote it could have put 3,100 or 2,900. Of course, this is kind of subjective, but we have that table in the best practices that suggests the best option that we should use. So now we have all the parameters for this calculation. Let's calculate.
Reminder about measurement error.
Oh, thank you. Yes, that's in kilometers still. Thank you. 2 meters. Thank you. There. So now we calculate. And we get an uncertainty of 4,700 meters, more or less. So this uncertainty, if you remember what we did before, is smaller than the one we had when we used kilometers. I will do it again in kilometers so that you see the difference. If this is kilometer, we're missing it for 1 kilometer. You see, we had 5,000. And if I do it in meters, I have, oops, 4,000 and something. Why? What are we doing differently here? What is the factor contributing to this change in the uncertainty when we change the units? Because we all know that 1,000 meters is a kilometer. I mean, we have no doubt about that. Humanity has no doubt about that so far, or more or less. But why is the uncertainty diminishing? If we kept all the parameters the same, except the units, that we change the units, but we convert this between units. So the values should represent the same amount. What are we changing here from one calculation to the other? Ideas? Yes, for free. Excellent. We're changing the precision. Excellent. So in the first calculation, we had 1 kilometer of precision. So let me write it down here. We had, when we had 3 kilometers, right? In the description, we said the precision is 1 kilometer. Now, when we have 3,000 meters, we're saying that the precision is 100 meters. So here, 100 meters is 0.1 kilometer. So we're being much more precise when we're using a smaller unit. And so that's why the uncertainty is because we're being more precise in the second case. So, excellent, Pulshari. Okay, anyone has questions about this? Should I pass to the next one? The next one is very similar. Did someone open the microphone? Anyone wants to say anything? Okay, I will move to the next. And the next one was, well, this is the one that we just saw. And this was the same, but including the direction. So you can try that one. And let's see, because John, I believe, had something that he wanted to show you. Do you want to show the other example, John? Yeah, because all of these things we have been seeing as we were going, and so it's just kind of repeating the same. So I will pass the sharing and pass. Share your screen now.
Okay, first, can you hear me?
No, you're muted.
It says here I'm not muted.
There. Yeah.
Okay. And you can see the screen okay?
Yes.
Okay, so what we wanted to do was to look at examples from a slightly different perspective. On the map, we've still got Winterton, and we still have a place with the red marker on the road R600 somewhere to the south of Winterton. And the question we're going to ask here is, how can I describe this place? And then look at the consequences of describing that place in different ways. So one way to approach this is just to think about each of the locality types on the calculator and try to describe that same place with each of those locality types. So the first one would be with coordinates only. And so what I've proposed here is the coordinates only description of that marker on the map. In this case, the coordinates came from a GPS and the person was conscious enough to give us the datum that the coordinates from the GPS came in, plus the higher level geography information. If we do a georeference based on that, let me switch over to Google Earth. I've got the same thing here on Google Earth. My marker is down here. It says, how can I describe this place with a yellow marker? Winterton is up here. And I'll just go directly to my result for that, which should be this. You can see that a circle around the place has been drawn. And I'll zoom into it. So that is the point radius representation of this description. And it has an uncertainty of 104 meters. Why is it so big? It came from a GPS. Shouldn't it be smaller than that? Anybody have an idea why the uncertainty is so big as 104 meters for this example? Any ideas? If not, we can go to the calculator and try to figure it out. What did John do to come up with 104 meters? Our description is a coordinates only description. And our coordinate source was a GPS. It came from the GPS. The coordinates are in decimal degrees. Let me make sure that I'm using the same coordinates. I'll copy and paste them just to be sure. Copy all of that at once, go back to the calculator, paste all of it together, and then put the longitude where it belongs. Okay, and I choose WGS 84 as a datum. The precision of my coordinates is exact. Now we get to GPS accuracy. What do I put there? Here's my description. What do I put for GPS accuracy?
The young man didn't record it.
That's right, it's not recorded. So what do I put in the calculator? Again, back to the description. Any ideas? We actually mentioned that earlier today.
Hello,
Yeah.
John. What is in the brackets there? 104 meters. I can see some 104 meters in red.
This is the uncertainty that I arrived at when I did the calculations.
Okay, but unfortunately, we are unable to get the dates for which these coordinates were picked. It could have guided us to choose either 30 or 100 meters.
That's exactly right. That's exactly right. So since we don't know, we have to be conservative and we have to go with the higher of the two possible values. And that's exactly the issue. I'm going to get back to the calculator. I have something in the way on my screen. For some reason the thingy is not getting rid of itself. So let me share this screen again. Sorry, I was unable to get to the calculator. Okay, switch to the calculator again. So because we don't know the date, we have to go with the conservative value of 100 meters for the GPS accuracy. And if it's meters, I need to change to meters. And then I do the calculation. Now, I already recognize, because I've done this a lot of times, that I made a slight mistake. And when I calculate, my uncertainty is not going to be exactly the same as what I said on the slide. There. The uncertainty is actually only the uncertainty from the GPS. The 4 meters that was there is my mistake. It should have been just 100 meters. And the only source is the uncertainty from the accuracy of the GPS, which we don't know because it wasn't given, and we don't know the date. So we have to go with the more conservative value of 100 meters. So very good. Now, what about doing the description in the next calculator type, geographic feature only. Well, we don't really have a geographic feature in that portion of the map to go on. There's nothing to describe where that is. So I don't really have that option to describe that place with a geographic feature only. Does that make sense? I need to use some other reference. The nearest thing I could use would be perhaps this building. I could do some kinds of offsets from that building, and that would be a good thing to do. I can't do a feature only. So let's go to the next one, which is a distance only. I have the same problem because a distance only is just like a feature only, except that it adds a buffer around it. So I can't really do that one very well either. So let's go to the next one. Distance along a path. So this is what Paula spent a lot of time describing, which was to start in the town and to come down the road to this place. Let me zoom out so we can get the town in there. We have Winterton. We have the road out of Winterton, and we have the endpoint. So one way we could describe that would be, sorry, I'm skipping the second one, going to the third one right now. One way to do that would be to say 3 kilometers south of Winterton on the R600, which is exactly what Paula was demonstrating. If I do that calculation, I end up with an uncertainty of 2,193 meters. So let's look at the results on the map. So this one should be 3 kilometers south of Winterton on R600. Now, the center is in exactly the same point, because remember, that's the place we're trying to describe. So all of our coordinates should end up being exactly on the same marker. But in this case, the way I've described it, by going south of Winterton on the road, I get an uncertainty that's much larger. And we've already seen the things that contribute most to that. In Paula's last part of her description for that locality, we found that the size of Winterton was what contributed the most to that uncertainty. In fact, it contributed 1,675 meters out of these 2,193. So the vast majority of it. The rest of it comes from the uncertainty in the distance precision, which we remember was 3 kilometers. So the uncertainty, the precision that we had to choose in the calculator was 1 kilometer. So I can do that calculation as well fairly quickly. I do a distance along a path. My source is no longer the GPS, but rather it's Google Earth and Maps, which is where I found the corrected center of Winterton from. My coordinates are in decimal degrees. My coordinate source is WGS 84, and they are exact for all intents and purposes. My radial, I guess Paula used 170.1674. My measurement error is 10 meters, but what we're doing here is kilometers. So I need to change my units to kilometers. And then my measurement error isn't 10 kilometers, it's 10 meters. So that's 10 meters when I convert it to kilometers. And my distance precision was 1 kilometer because the description said 3 kilometers south along the road. So those are all the parameters for making this calculation. I do the calculation and I find my answer is 1 meter less than what I put on this slide, because I used 1 meter more for the size of Winterton than Paula did. Okay. I'll correct these as we go. Why not? Okay, so that's a second way to describe that spot. I'll go back to the second one now. Sorry that I skipped it in order. The second one is exactly the same as the first one, except, we'll go here to not confuse things, exactly the same as the second one, except that we don't know that it came from GPS and we don't know the datum. So what does that one look like when we map it on Google Maps or Google Earth? I'll take away the second one and I'll put in the other one. Wow, we get a big circle. This is a more than 5 kilometers circle for the place if it was described with just the coordinates and nothing else. So that is to hammer again why the datum is so important, or if it comes from a GPS, to record that it comes from a GPS, and therefore we can get the accuracy much greater. So that tiny little circle and this big circle are exactly the same description as a point, in one case with datum, and then the other case without the datum. Big difference. Now we'll shut that one down and we'll go back to our descriptions. We already did this third description by road. The next one on the calculator should be a distance along orthogonal directions, but I think I did it in the other order. I think I did a heading first, distance at a heading. So let's go back to here and see if that's right. Yes. This fourth description, if we look at this most specific part of the locality, is a distance at a heading from a feature. Our feature is Winterton again. Our distance is very specific. It's actually meters, but expressed as kilometers. And our heading is very specific as well. It's not to the south or south-southeast. It's actually at 166 degrees south. So let's do that one in the calculator. The type was distance at a heading. Our source again is Google Maps. Again, decimal degrees, same coordinates, same datum, same coordinate precision. This time, we're doing degrees from north. And when we do that, a new box shows up here. Let me show what happens if I just said north. If I said just from north, there is no box here to enter the direction precision, or the specific direction in degrees rather. Instead, if I pick degrees from north, now I have the option to put in 166, which is what was in our description. 66 degrees from north. And our offset distance was 3.293, if I remember correctly, in kilometers. And our radial for Winterton is still 1.674 kilometers. My measurement error, personal measurement error, is still 10 meters, so 0.01 kilometers. In this case, though, our distance precision that was in the original description is to the 1,000th of a, 100th of a kilometer is the best we could do here, but it's more exact than that. It's to the 1,000th of a kilometer, or 1 meter, which here would be exact. Does that make sense? If I calculate that, I get another number, 1,693, assuming that I put the offset distance in correctly. And on the map, we are using this circle. So you can see now, I need to zoom in a bit. And now I've got a new circle. I'll compare it to what happened when we went down the road 3 kilometers. That was a bigger circle. So we're actually more precise, using a very precise distance at a very precise heading to the place that we're trying to describe. So now I'll shut off those two. And I'll go back to the other example, which again, I'm unable to get to my presentation. So let me stop share, start share again. Sorry about this. Go to the presentation. So the next one on the list was distance in orthogonal directions. So here I've got a distance south and a distance east from the reference feature Winterton to get to my final answer, to my final place on the map. So let's do that one in the calculator. We'll remember 3.2 kilometers south and 0.78 kilometers east. Distance in orthogonal directions. Everything here is the same. 3.2 is the distance to the south. Here, 0.78 kilometers to the east. The radial of Winterton has remained the same. My measurement error has remained the same. My units are still kilometers. But now my distance precision is expressed in these two values. One says 3.2 kilometers and the other says 0.78 kilometers. I'm going to follow what the best practices document says and use the more specific of those two as my distance precision. So in this case, it should be 0.01 kilometers or 1/100th of a kilometer. And then I do my calculation. And I've done everything correctly. I get this orthogonal directions interpretation. So let me turn on all the interpretations again. And I'll zoom out so we can see them all. In the very center, we have the coordinates only where the GPS was stated as a source with a WGS84 datum as the setting for the GPS at the time. And we had a very small radius. So that was a very good way to describe the place. We also have the next one out. The next smaller one was the directions at a heading where the heading was very specific, 166 degrees, and the distance was very specific to the basically to the nearest meter. And we have this next circle here. After that, almost exactly the same in terms of the uncertainty were the distances at a heading. That's this next circle. In that case, we had distance precision that was less than that when we did distance at a heading. So that maybe contributed to the difference there. The next one out was using the distance along the road. That's this one. And then finally, the biggest one was the coordinates only, not giving us the data, not giving us a GPS as a source. So my question to you is the following. We've said in the past that distance at orthogonal directions is a very good way to describe things and that it's very specific. And I've also demonstrated an example of using distance at a heading where both the distance precision and the heading were very precise. So why are we getting big circles in those cases? What's going on there? Anybody have any ideas? Anyone? Why do we have consistently big circles for 3 of the locality types that should be fairly precise? And why are they mostly the same? Any ideas? Be brave.
Maybe you can show description again, the slide with the descriptions.
The slide with the descriptions shows these. The difference between the first two is clear. But why why are the last three so big?
The question is actually similar to what I was asking before when we were doing the other exercises. Which are the factors that are contributing to these uncertainties?
We have an answer in the chat. We've got some messages in the chat. So Seram says the extent from the feature is affecting the uncertainty. That's exactly right. So if we go down one more slide and look, what is the radial of Winterton? Winterton is our feature of interest or a reference. In all of the last three, Winterton is where we started, and Winterton is contributing 1.675 kilometers to the uncertainty in all three of those last three localities. So good job there. What does that tell us? It tells us if we're going to do any description that uses a reference feature, we will be better off if we can choose a feature that's very specific, very small. Winterton was a big feature. And so the end results can't be any smaller than the radial of the place that we start. It's so uncertain where we started. But if we were to use, for example, on the map, if we used the intersection of the roads inside of Winterton, and I think there's an intersection right here. If we use this little plaza or intersection of roads as our starting place, then we would have a tiny circle from which to begin. And all of that uncertainty to Winterton would not contribute to our final result. And so all of our answers could end up being much more in keeping, much closer to the description that was this one. They could even be better than the GPS one if the descriptions take away all of the uncertainties, especially the one that's contributing most in this case, the radial. Are there any questions about all of this part? It was to view the georeference from the other perspective. What different ways can I use to describe the same place, and what effect does that have? And what should I be careful of when I make those descriptions in order that my uncertainty radius can be as small as possible? Any questions about this? Or observations? Does it help to see it this way?
At some point, Maurice was saying that the second one is tricky. If you could please explain it again. I'm not sure if he still wants that explanation.
The second one that I did, which was the on the road. The road one or the, yeah, okay. Can you be more specific about your question about this one? It's the one along the road, is that right? You can open your microphone too if you like.
Yes, specifically, I just want the above one, the above, yes, that one.
This one. Okay.
Yes. Thank you.
Right. Okay, let's go to the calculator with this one. So the coordinates came from the locality description. This is all that we had. The part in red is something I provided after the fact. So let's go to the calculator. It's a coordinates only calculation where the coordinate source was the locality description. It didn't tell us it was from a GPS. But it did give us the coordinates in decimal degrees. And it did give the coordinates out to 6 decimal places. So that's the equivalent of exact here. But it did not give us the datum. So we need to choose datum not recorded here. In the case of the coordinates only, like this, I made no measurement whatsoever. This should be 0. And because it's 0 and it's the only thing that has distances, it doesn't matter if I pick kilometers or meters, it's all 0, meters or kilometers. And then I make my calculation. When I do so, I get the uncertainty basically due to the unknown datum. Nothing else contributes. And that value is dependent on latitude and longitude. Does that help explain why that one's so large? Okay, great. Yeah, it was about the datum. Any other questions about any of this or anything that Paula said before?
There is one, but that just came to me.
Okay.
But I will read it out loud. What is the exact answer when you have to describe a place? Does the answer include all steps made in the calculator?
So this is a perspective issue. And I think I've seen this in some of the exercises for module 4, where what you have done, some of you maybe, have done is to provide a description after the fact, after having georeferenced. But that's not what we want. What we want is to use the original description exactly as it was given to us and interpret it by the rules of the protocol, to follow exactly the steps of the protocol to interpret what that original locality says and arrive at a geospatial description as a point radius with decimal latitude, decimal longitude, geodetic datum, and uncertainty in meters. We don't want to describe the place again based on that because our description will be different from the original. And if you did a georeference on the interpreted description based on your georeference, you would get yet another georeference, not the same place at all. So you don't want to go through that loop. Your life is easier than that. All you want to do is provide the georeference to go with the original location. Don't describe it again. Does that make sense? Am I answering that question correctly?
One thing I would like to add is that while we georeference and we look for information in different sources, etc., we might find interesting data, interesting information that clarifies what the location is about. But we don't have to modify the description, as John was saying. However, we could capture that in location remarks or in georeference remarks, depending on what we're commenting on. So it's not that information that you find is going to be thrown. No, it's really important that you document all that and document your assumptions and the things that you find while you're referencing, because that can help other people down the line. But we never modified the original description. Okay, I don't see any more questions on in the chat, nor hands up. Does anyone have more questions?
Yes, I have one question here. Hola.
Okay.
Please, how big is an uncertainty? When should we be alarmed and suspect something?
I'm not sure I got the question. Can you please repeat it?
I want to know how big is an uncertainty? How big should it be before we get alarmed and suspect some more, especially if we could go back to the field for some collection or for more information?
That's a very interesting question. Uh, it varies a lot depending on the kind of information that we have to do the georeferencing. In some cases, it's very imprecise, the information that we have, and it's going to have a large uncertainty. And there's nothing we can do about it. Like, for example, if we have a record that only says Kenya, well, it could be from anywhere in the country. So the uncertainty is going to be very high. We don't get alarmed by that because it is what it is. It is high. When you try to go to back to the field to look for some specimen in particular, for some species, what we usually try to do is use the geographic information, but also use other kinds of information. Like, for example, the informations from the collector's diaries and the information that we have, for example, on where a biological station is, and one that one can suspect that, well, the place cannot be very far from the station. When we georeference, we have to be strict. And if we don't know something, we don't know it. We cannot guess. But when we go to the field, we do use that accompanying complementary information to narrow down the locations. There is no universal solution, however, there is no universal answer. John wants to add something. Yeah.
Yeah, using your example, Paula, of the research station. So there is a circumstance under which you could use a field trip to try to discover more precisely where a place is. For example, suppose you have a plot number that's, your description says some plot number at some field station. And it's a place that you go to all the time, but nobody's ever provided the coordinates of the plot. They've only provided the coordinates of the field station, or you can see the field station on Google Maps or Google Earth. And so without going back to the field, all you could do is describe some region around the field station. But the plot's more specific than that. So you could go to the field and with a GPS, go to the plot, go to the middle of the plot, take the coordinate. If you really want a precise or accurate set of coordinates for the plot, you take the GPS reading several times, and you take the average of all the GPS readings to get the center of the plot, and then describe your accuracy as being the biggest distance off that any of your GPS readings were, and then use that ever after as the coordinate for the plot, with the size of the plot being the distance from where you took the coordinate in the middle to the furthest corner of the plot. Then in the future, anytime the plot was mentioned in a locality anywhere, you could use that instead of just the field station. So we would call that ground truthing. Sometimes it's possible to do that. Sometimes it's not. These have been great questions today. Very happy about all these questions.
Are there any other questions?
You're all sturdy souls to stay so long on the very last
Yes.
day. Speaking of which, I think Paula has something else she'd like to say.
Yes, but I'm going to formally close then this workshop. Thank you everyone for your participation in this workshop. It has been great and a lot of work from all of you. And well, we'll keep communicating with you with respect to the exercises and so on. I will add some comments after we're done with the live recording. Oh, well, this is a very big thank you. And with this, we are finishing the last session of the African Plants Georeferencing Train the Trainers workshop. Well, hope to see you in the next training. I will stop.